Hi, I'm James Wen, and I'm from Spotify, and I'll be talking about making an internal Kubernetes offering generally available. So we're currently in the process of migrating our runtime over to Kubernetes at Spotify, and it only took about 2 years to go from just 2 developers investigating the potential usage of Kubernetes at Spotify to going to having a full GA, generally available offering for all of our developers. And so we've given past talks about the first few migration phases, but this talk aims to share on kind of the latter parts and what it went into bringing our GA offering over like the finish line, in a sense. So quick about me, I'm a senior SRE at Spotify. I started out on a team that worked on provisioning and DNS, and now within the same core infrastructure organization, I'm on a team that maintains deployment and is one of the teams responsible for our Kubernetes migration. So in terms of the agenda, I'll briefly introduce Spotify, how we do operations, and what our runtime looks like, what we're migrating from, to kind of see the context there. And then we'll dive into the GA journey and cover some learnings and takeaways. So very quick about Spotify. We're an audio streaming platform across a variety of different devices, and we aim to connect millions of artists with billions of fans. In doing so, we have a fair amount of users and subscribers who listen to a fair amount of audio content, and all of this is supported by a large amount of engineers across a large amount of teams that are maintaining a lot of microservices that get a fair amount of load and generate a fair amount of data and events. So how are these engineers doing operations for these applications and microservices? So if we have like an operational spectrum where, say, on one side you have teams that have complete team autonomy in how they do their operations, they can deploy or run stuff, set up metrics using whatever tools or processes they want. And then on the other side of the spectrum, you might have like a centralized ops team that is responsible for all the DevOps related things for your product and is responsible for like ultimately your product being up and running. Spotify kind of operates in the middle with like an ops and teams model. So here, teams build their own services. They are operating them as well, but they're doing so using pretty extensive tooling and like a platform that the core infrastructure organization provides for them. So they're still doing operations, but they're doing it at a much higher abstraction level. And a great actualization of this is something we call the golden path. So this is an opinionated, blessed like set of best practices for building and operating services at Spotify, which includes a pretty comprehensive tutorial that developers can follow on like their very first day to build a new service, like put it into production, and set up things like metrics, alerting, on-call for it. So let's talk quickly about our old runtime, or what we're migrating from. So our old runtime involves having like one Docker container or like instance of a microservice per host. And the host configuration and setup is done by Puppet, and the Docker orchestration is done by Helios, which is our own open source container orchestration system that was conveniently announced the day before Kubernetes was. So we're moving from that old runtime to our new runtime, Kubernetes, or more specifically, like GKE. And with our offering, with Kubernetes, we no longer need Helios or Puppet. The concerns and like management around Docker and like GCE hosts are now offloaded to GKE, which has let us build a much more advanced like Kubernetes offering for our developers on top of it. That is using soft multi-tenancy and is a multi-cluster internal offering. And I think the last piece of like important pre-context is that our goal for this migration has been scoped to running all stateless backend services at Spotify on Kubernetes. And if you're interested in some like the earlier migration phases, because this definitely wasn't like a big monolithic migration effort, you can see some previous talks we've given on that. So general availability for our offering, like what does it actually mean? How do we define it? So we roughly defined it as any new service at Spotify would be deployed only to Kubernetes and have full integration and support for both the like pre-existing ops tooling and also like new native Kubernetes benefits and features that people wanted to use. And an additional piece of this was that teams with existing services on Helios could fully migrate them over in a pretty easy self-service manner. And so this has been pretty successful so far, if I do say so. And even though we're not currently like actively pushing or forcing our developers to move over to Kubernetes, we've seen that roughly 33% of eligible stateless backend services have moved over to Kubernetes. So to put that in perspective, like all of these migrations were done by teams that did so through the self-service experience, and they did so on their own, of their own volition, like on their own time. So now let's get into what we had to do to actually make the offering ready for general availability. These break down into like a few big domains, the first being operational solidity, kind of like scalability, reliability, observability. The first topic I want to talk about here is our multi-cluster strategy and how we manage the clusters. So we started out with just three production clusters, but now we're running about like 2,500 fairly large nodes across 15 production clusters that are across like 3 different regions. And so in the beginning, we had automated scripts. They were pretty quick to create, quick to change, easy to run, that did all of this like cluster creation and management. But as we scaled up with more clusters and those clusters got more complex, we started to encounter a few issues. For example, these scripts were not idempotent in the case of like the script failing out in the middle of it. And additionally, the creation part of the scripting, which I would say is the most important part actually, that wasn't something that got tested or executed that often, like in practice, because we weren't creating new clusters all that often yet. And so we moved to a declarative approach with Terraform. And if you're interested in some like deeper details on our experiences there, my colleague David gave a really great keynote on that last year at KubeCon. And the takeaway for like the multi-cluster strategy and our management of it is, if it's possible, offload the cluster management. What we realized is that somebody has to be like consistently concerned with making sure that cluster creation, bootstrapping is like up to date, work as expected, that kind of thing. And it's really great to be able to offload this to like an open source tool like Terraform, or like a managed solution, or like a provider of some sort. The other aspect of our multi-cluster strategy was deployment. How is the deployment to multiple sets of clusters occurring? And so here we were able to leverage an existing deployment system that we had called Tugboat, which served as our like deployment abstraction layer for developers. And so this existed before our move to Kubernetes. The kind of left branch there already existed and was how people used Tugboat to deploy their services to Helios. Namely, their CI/CD pipelines would basically talk to Tugboat, and Tugboat would orchestrate the deploy out to GCE. And so we kind of hid or built our deployment to Kubernetes behind this existing abstraction. That's that right branch right there. And how multi-cluster plays into this is that we built a service called Compass, a fairly simple service that Tugboat will talk to basically request what clusters should I deploy this application to. So for that example request there, Tugboat is trying to deploy playlist proxy. It sends a request to Compass saying, I have this application called playlist proxy that wants to be deployed to the US and Asia regions, and it wants to be in 2 clusters per region. And then Compass will basically return what clusters Tugboat should deploy that application to. And that assignment of applications to clusters is like a sticky assignment so that people's deployed resources, they stay on the same clusters across like multiple deploys. And the current behavior for Compass is that we select clusters based on available capacity, and we also added some features around like reliability, that clusters per region thing that I mentioned. And our guiding principle here was to try to keep it simple for developers to reason about. Even though we're running on, we have a multi-cluster offering, developers, what we assume most of them cared about was the regional level, especially as their failure domain, not on a per cluster level. So this has proven to be pretty true, and what we wanted to do on the deployment tooling layer was that just ensure that their app is on some cluster in the region that they want to be in. If you're interested in I'm plugging a lot of different talks here, but if you're interested in some of the deeper details around our multi-cluster strategy and also some things around scalability with running large clusters, my colleague Austin and Jago from Google are giving a talk on this tomorrow at KubeCon. So let's move on to operational metrics and alerts. So this is for us as the owners of the cluster, not specifically for application developers using the clusters. So we had to set up pretty solid monitoring on integration components, error, latency, saturation on these components. So what do I mean by integration components? These were things that we as the cluster owners were running on the clusters or interfacing with the clusters that provided integration with our existing infrastructure. For example, things like service discovery, IT general controls, and our in-house secret system. So we wanted to monitor those pretty closely and ensure that those integrations kept working. We also had a pretty important smoke test metric that would basically periodically deploy a test app to our clusters. And this was less about the cluster health and more about the deployment tool chain and making sure that that was working end to end. We also set up a lot of metrics around available cluster capacity, the scheduling, status of backups, and we set up alerts for all of these as well. And the takeaway there is it's a really great chance to establish trust through monitoring for your offering. Basically, make sure that you have whatever metrics or alerts that you need so that you, as the cluster owners, are aware of issues or cluster degradation before your tenants on the clusters are. It goes a long way towards establishing confidence in your system when, if they have an issue, they might pop in your Slack channel or something and then see that you're already aware of the issue and also working on it. The next thing we did was around dirting. So DIRT stands for Disaster Recovery Test. And so we planned and executed a few DIRTs around, primarily around cluster deletion and the master being down. And these validated and improved for us metrics and alerting. They made sure that we had the proper metrics and alerts set up to be able to be aware of the situation during these DIRTs. And also it validated that our playbooks were working as expected, specifically around things like cluster creation, backup restoration, and it validated that our backups were actually working because during the cluster deletions, we had to restore resources that we had backed up. Because as they say, if you don't test restoring your backups, you don't actually have backups. So this ensured that we actually had backups. And the takeaway here is to plan for and simulate failures before general availability. Whether you're operating your own Kubernetes clusters or you're using a cloud-managed offering of some kind, don't make the assumption that the clusters will always be there and be stable. Have a plan and processes in place for when this assumption is broken. Also, I would say to not assume that cluster deletion or absence is the only failure scenario. We learned pretty different things from the cluster deletion DIRT test versus the master being down. So think about different scenarios as well. The next overall domain is something in the realm of business impact. Here we set up metrics and dashboarding around things like resource utilization, cost, percentage apps migrated, developer productivity. And so this wasn't just for us, but also for developers. Things like the cost metrics were pretty important because it allowed developers who were migrating their workloads over to see how much they saved by doing that migration. And so far, cost attribution and savings have proven to be one of the most compelling reasons for developers to migrate over to our offering. And it's also very important for us as the cluster owners because it allows for things like cost tracking. This is a graph of our cost over time of microservices that are currently fully migrated over from Helios to Helios on GCE to our Kubernetes offering on GKE. So a quick explanation of what you're seeing here. In our old runtime with the one service instance per host, we didn't have bin packing, and we also had some limitations around auto-scaling. So once with the move to Kubernetes, we have bin packing and auto-scaling, and our cost savings are kind of showing that. And that little spike you see at the end is due to some relatively minor recent incidents that we had where auto-scaling played a part in mitigating the impact. So the takeaway for having these kind of metrics is to, before GA, track enough data to answer questions from a business perspective. And it's also important because business-related metrics can be difficult or not as effective if you add them later. For example, if we just started tracking cost when we went GA, then we wouldn't have been able to produce a cost over time graph or analysis like that. Make sure you give yourself enough info or data to answer things like, how can I tell if my migration or my Kubernetes offering is a success from a business standpoint? The next domain is around self-service. So to give some context here, teams at Spotify have a lot of choices about what they want to run their stuff on. And our aim here was to make the Kubernetes offering the best choice for most developers. And so part of that involves having a very smooth and easy user experience around actually getting onto the offering. And so the first aspect here was namespaces. So what is involved in the developer or team getting their own namespace that they fully own and have full control over. So we had this GKE onboard Docker container that we supplied to users that they could run locally on their machines. And this would basically generate the proper namespace-related resources for their team or desired namespace on a monorepo called system resource manifests. So to explain this, our resource manifest distribution model, in a sense, is that the resource manifests or resources that we want applied to all clusters. So for example, things like namespace information, things like integrations that we as the cluster owners operate, these go into this SRM, system resource manifest monorepo, and get applied to all clusters. And then for people's resource manifests that are related to their application, those live with the actual application repos. So there's really just one step for a user or a team to run to get their own namespace. And the takeaway there is to not be afraid of taking complexity for your developers. I'm speaking from the standpoint of being a person in infrastructure who owns the Kubernetes offering. I think it's always said things keep it simple, but you shouldn't necessarily keep your design of the offering behind the scenes simple if that introduces extra complexity for your developers. Don't be afraid of making things a little more complex under the hood so that, for our case, developers only have to run a single Docker container to get their namespace set up and ready. The next aspect is around applications. And so they have their namespace, how are they actually getting their applications there? So this shows what the workflow was before Kubernetes. The kind of dotted box there is what is in their application repo. And here it is a Helios configuration file that the CI/CD pipelines basically run these two commands related to Tugboat on to create a new version and then set that as the desired target version. And that causes Tugboat to actually deploy out to GCE and Helios. So with the Kubernetes experience, or say migrating from that to running on both Helios and Kubernetes, all developers had to do was basically run this cookie cutter tool that we provided them to get like a working set of manifests for their application, and then also add this like YAML file shown on the right called like deploymentinfo.yaml that specifies, in this case, I want to deploy to both Helios and Kubernetes. And so the CI/CD pipeline part stays exactly the same. It's the same exact two commands, tugboat commands that are being run to then deploy to Helios and GKE Kubernetes. So that the top right boxes are like all that's new. And then after that, if they want to remove the Helios capacity, or if they're starting out like with, say, Golden Path, and they're only on Kubernetes, that's what this would look like. And I think the thing I want to point out is that in this deployment info YAML, they can also specify like very high-level deployment or like Kubernetes-related configuration. For example, like the regions that they want to be in, things around like region redundancy with like clusters per region, things like whether you want a canary also goes into this file. And our takeaway here was to use existing tools and abstractions wherever possible to make it as frictionless as possible for your developers to migrate over themselves. So like Tugboat was deployment for most of our developers from both like a tooling and like an abstraction level kind of perspective. So we hid and built the Kubernetes deploying process behind this existing abstraction. And because of that, like the CI/CD pipeline stayed exactly the same, and the overall deployment workflows that developers were used to stayed the same, and how they conceptualize deployment stayed the same for the most part. The next aspect is around documentation, everyone's favorite, which has become our favorite as well. We wrote an extensive amount of internal documentations, and these are always like a work in progress. You're always iterating on them, and our like FAQs, we put that onto Stack Overflow Enterprise, our internal like Stack Overflow Enterprise in the form of questions, and we also had to update that like backend Golden Path tutorial that I mentioned to deploy to Kubernetes by default. And in writing this documentation, our kind of like guiding principles were to assume as a baseline that our developers do not know Kubernetes, but we did find it like difficult to strike a careful balance between informing them of what Kubernetes is and avoid rewriting like the open source documents out there for Kubernetes. And for this, we basically leaned on linking to the open source Kubernetes documents wherever relevant, but we made sure to like enhance it with Spotify-specific content. And for documentation, I think it's pretty important to remember that you, as the owners of the offering or the clusters, are not the intended audience for the documentation. Your understanding of like Kubernetes or even infrastructure in general does not represent what your readers are going to understand or like approach your documentation with. So even if you have very good documentation, developers will always find a way to have questions or like advanced use cases that they will want to ask you about. So for us, we established support shifts covering both of the main time zones that our developers are in, specifically like US East Coast and 2 time zones in Europe. And when I say support shift, this isn't like some third-party support or something like that. This is people on the teams who own the offering and have designed it and like work on the infrastructure behind it, basically being interruptible during these shifts and being responsible for answering questions and discussing with developers any questions they may have about the offering. And we found that this process can be really mutually beneficial. It's a really great two-way experience. Your users or your developers who are using the offering get the support that they need, the dedicated support from the people who created the product in a sense. And then you as the cluster or like the offering owners get to talk firsthand with your users about what issues they're having. You can really see like what parts of your docs might be confusing. You can find potential improvements in the user experience. A lot of the user experience improvements that we added were basically from us during our support shifts, noticing common trends or repeated issues that our users who are trying to get onto the offering were having. And the next section is feature parity. So I left out some of the stuff around that's maybe more specific to Spotify, including stuff like our internal technical portal or UI, ITGC, event admission. We needed support with all of these, but I'm not going to talk about them too in detail because of time constraints, and it's a little company specific. The one I'm going to point out is canary support. So this was an existing feature that we had in Tugboat for Helios. Basically, developers would specify that they want a canary for their deployments, and it would deploy to that first, and then it would receive production traffic, and then you would hit a button to advance that to the rest of the production hosts. So we built a similar feature on Kubernetes via Tugboat, where we would basically have Tugboat deploy out a separate set of resources, suffix with -canary, for the resources that were appropriate, but in a way that these replicas would still get production traffic. And so the takeaway here is that for your offering, developers need feature parity or better. So the first part, need feature parity. The important operational things or features that developers were doing with the old runtime, they need to be either able to do the exact same things, do the same things, or in this case, for Puppet, not need to do them anymore. And then when you're deciding what features you want to basically have in place before GA, it kind of depends on how widely used the feature is and how business critical it is. I wanted to talk more about canaries for this example because a lot of our production services are using canaries in their workflows, and a lot of business critical applications are as well. So it's not something that we could go to general availability without supporting. And so our general availability requirements kind of fell into these four main categories that I covered. Operational solidity, so reliability, scalability, observability, business impact, basically the correct metrics tracking and the ability to answer business-oriented questions. Having a good self-service experience that was frictionless and smooth, and important feature parity. Again, the important things that developers do with the old runtime, they need to be able to either do the same things or not need to do them anymore. And then if you're interested in hearing some of the future plans we have for our offering, because I may have mentioned in the first slide, there's crossing the finish line. There actually is no finish line. We're always iterating and trying to improve things for our offering. So the first thing is, as I mentioned, we scoped the migration to stateless backend services. So we are potentially looking at maybe supporting stateful services in the future. Data jobs consolidation. On the data infrastructure side, there are separate clusters and a separate offering for running data jobs. There's always been talk of consolidating the two. And then cron jobs as first-class citizens. So although we allow developers to run cron jobs on the clusters, it definitely doesn't have the first-class support that things like deployments do, because again, it was back-end stateless services that was our primary scope. So this one's pretty near and dear to me myself, basically supporting cron jobs as first-class citizens. And then higher level abstractions. So with this, right now, developers still have to know what a deployment is, what a service is, what an HPA is on some level. Maybe one day there will be a Spotify microservice custom resource that they can use that would abstract all of this away from them. And so I want to cover some general learnings from our migration and general availability, journey to general availability to end with. So the first is to be mindful and deliberate in dictating terminology. So what I mean here is that when you're adopting or using Kubernetes, you're not really adopting or picking up a single tool or technology. You're really picking up an entire ecosystem. And with that comes a lot of overloaded terms like deployment, services, endpoints. These can get actually pretty confusing when you're discussing with developers or like in things like documentation. So being aware of this and doing even what are maybe considered little things like always italicizing or capitalizing like resource types, like deployment service in your documentation can go a long way in like alleviating that confusion. Migrate in stages or series of goals that increase in scope. So as I mentioned, we definitely wanted to avoid a monolithic migration for this entire process. And by basically having like a series of little migration stages that had different scopes, we were able to like discover and deal with a lot of unknowns and like hidden problems at a pretty controllable pace. Like we found out things at this stage, found out things at this stage, versus undergoing a kind of waterfall monolithic migration and ending up with a lot of unknowns hitting us at once. And then the biggest learning for GA is that developers will adopt and or migrate to your Kubernetes offering if it is easy, complete, and compelling. So this is kind of a refining of the saying, like, if you build it, they will come. That's not true. Developers are pretty busy and they hate complexity and pain. So if you implement your offering in a way that has those things, they're not going to migrate to it. But if you design your user experience for your Kubernetes offering in a way that is like easy to use, get support for, move on to, it's complete in the features that developers are currently using and perhaps expect, and then also is also compelling in that it introduces new features that they want. For our example, like auto-scaling, then despite having pretty busy backlogs, developers will find the time to move over. We've seen that firsthand. And the last thing is to talk to other companies about how they do infrastructure and solve infrastructure problems. So another talk plug, but 2 years ago, one of my colleagues, Dave Zolotuski, gave a really great keynote on this, basically about our joining the CNCF and the impact that it's had. And basically, like since we've joined the CNCF, we've greatly increased the amount of time that we spend talking to like our infrastructure counterparts at different companies about how they use Kubernetes, about like infrastructure problems in general. And so in doing so, we've learned a lot from them. They've hopefully learned a lot from us. And we've learned a lot in terms of like potential approaches, pitfalls to avoid, that kind of thing. Just as I hope in sharing this talk, some of our experiences here at Spotify resonate with all of y'all. So thanks for listening. If you're interested in working on these kinds of problems or you just want to work at Spotify, we are hiring. And my email and social media are up there, and I'm always happy to talk about infrastructure, technology, Kubernetes, whatever. Please reach out. Thanks for listening. Time for questions? Or?